Welcome back to this class again, where we are talking about the sulfides or bisulfides. So, we can have the good source of sulfide as your hydrogen sulfide gas H2S or the corresponding sodium salt, that means the sodium sulfide. So, the reaction is very simple. When we react with this with sodium hydroxide, 1:1. Remember, this reaction is 1:1. If we go for 1:2, we will be producing sodium sulfide. So, the production of this for 1:1 giving you NaHS plus H2O. How you use this one? This is a very simple reaction. You bring H2S in it, because not only you have to remove one sodium ion from it, you have to incorporate one H plus. So, as more and more amount of sodium sulfide you will be able to produce from hydrogen sulfide, in between you can use this particular reaction where you can utilize a 50-50 mixture or 1:1 mixture of the original hydrogen sulfide along with your sodium sulfide, giving you twice of NaHS. So, it is a very simple reaction and very useful reaction for making your hydrogen sulfide. So, it is a huge application of this, because all these times what we are talking about, how you produce it and what are those applications basically. The reacted things and all other things are very trivial sometimes, is not a special type of thing. So, in the paper industry, for paper production, again as a useful reducing agent, so 40% of the material what industry produces as sodium bisulfide is consumed for paper production. Then for other cases, the ore flotation, and this is nearly this range, that is 35% of is being utilized. Then for making dyes and chemicals, including the pharmaceuticals, the agrochemicals, in the food industry, everywhere. So, this is also a very good component, that means about 12%. We are using is a global picture, globally we use it. Then less amount for leather industry, which is about 9%, and other uses about 4%. So, we see now that the sulfur bearing all these compounds giving us some good informations about their production and their utilization, but we will finish this particular class based on sulfur if we take one typical example where large amount of a liquid material or a solvent material is being produced, which is nothing but your carbon disulfide. It is your CS2. We use it. We have used from our school days, but we do not know how we produce it in a large quantity. That means our goal is that you have to produce it in large quantity. That is why you need a industrial technique. Why we require this technique? And which is also be cheap, and we should apply this particular procedure on some easily available material. So, if you have this carbon and sulfur in your hand, so what we do, we basically from the scratch we should try to go for a reaction between these two. That means a typical reaction between carbon and sulfur. Sulfur, as we know that it can be your S2 or S8 is the elemental sulfur in your hand. Then large amount of carbon source also we can have, the carbon as the different feedstock, and we can have the typical source of your carbon from your methane, and you can have the corresponding carbon from your CNG also. But there are some countries which do not have much of this CNG source or the methane source. They can have a different types of mechanism for this particular reaction. So, you can use directly from carbon from all these sources which are not based on your compressed natural gas or the methane source. So, you can directly use all other carbon sources. You can have your charcoal black or the animal charcoal black and all these for the countries which do not have the typical methane source in it, and it basically gives you a reaction between these two at a high temperature. So, this high temperature reaction in brick lined retorts, in a brick lined retorts is the reaction chambers. So, you have the brick line because you can have the high temperature withstand for this, and this is the first thing what we use, and the second thing what we will be using there is your corresponding furnaces. So, you have to generate the high temperature and you should get the corresponding control of the temperature also. So, is electrothermal, electrically heated furnace. So, is electrothermal furnaces. So, electrothermal furnaces where you can have the corresponding regulation for the temperature, because you have to produce, you have to optimize the corresponding reaction condition for this particular production. So, if you do not have your CH4 or CNG source for those countries where you do not have your CH4 or CNG, we use other carbon sources and high temperature brick line thing we can use. But if you go for simple use of methane, that would be much easier to react with that of your twice S2, giving you again that CS2, that means carbon disulfide. So, you will be producing CS2 plus what? So, our goal is for the production of your CS2. So, we got that this carbon will be reacting with this sulfur as sulfide. So, you have this. So, you have this carbon disulfide like carbon dioxide. As we burn it oxygen, we get carbon dioxide from the carbon sources. So, when we burn in sulfur environment or in presence of sulfur, we get carbon disulfide. So, what you get basically over there is that this one, so where this hydrogen will go, this hydrogen again presence of sulfur source, because we know that the hydrogen burning in presence of sulfur will produce H2S. So, this is your byproduct. So, byproduct H2S is there in your hand, and this can be utilized also if you do not require the production of your H2S, you can take it back for the production of elemental sulfur, because we have seen earlier that H2S can be a very good source for the production of sulfur, which is a solid powder material which you can store, but H2S is a gas, you cannot store it for a huge area. So, the preservation is difficult for H2S. So, better way to make it or quickly convert it to sulfur and store the sulfur, which will be industrially useful. So, again the Claus plants or the reactors can be utilized for the production of elemental sulfur from the H2S, which is your byproduct during the production of your carbon disulfide. So, this liquid you get now, and you have to purify. So, you have to purify it for some unwanted material. You should know the corresponding boiling point. You should know when you have the liquid sample, when you have the solid sample, or when you have the gaseous sample, how you purify those. So, this particular one is purified by distillation. So, it is a very simple technique, but is a huge scale. So, is a industrial distillation process will be utilized for the production of pure quality of your carbon disulfide. So, this particular one is very easy to make. Now, we will see its uses and applications. So, always you should try to guess when you are handling some chemical or you produce some chemical industrially, you should have a chemical sense, because the whole area of this particular study is dependent of your chemical sense, or is dependent on the economics also. People study the chemical economics, how the economics of a particular country is dependent on the amount of resource, the mineral resource or the ore resource or the natural resource, what we call, is effectively utilized for the production of different types of value added compounds. But in our country, we do not have that particular activity. We just simply use all these in some specific applications, and for some specialty material or the specialty chemicals, we are always dependent on some other countries. But there are some very simple, very trivial compounds available like this, like your carbon disulfide. So, the use and application is typically what you can consider it as, because we have introduced carbon to your inorganic sulfur. So, you can consider it as a organic compound, but we never consider your carbon dioxide is an organic compound or organic gas, but we can consider it as, because it is a liquid and it has a very pungent smell. So, you can consider it is a organic liquid. So, what you are handling basically, you see, what you are producing is a compound starting from your inorganic sulfur, and carbon is also an inorganic component when it is in the carbon form. So, you get this particular compound. So, you have this organic liquid. So, organic liquid, you can use it in a very simple way, that the first application what you can write quickly is a very good solvent. Therefore, you know the boiling point, you know the flash point, all of the data sheet for this particular solvent you can know, and its solubility for other compounds, whether some other compounds are soluble in this particular solvent, particularly if we consider that whether acid or elemental sulfur is soluble in carbon disulfide or not. So, that is a very interesting area of understanding, and we have given that example also right now, that when we go for this some sulfide compound with some extra sulfur, you get some polysulfide or the tetrasulfide. So, definitely your sulfur, elemental sulfur, that S as S2 or S8, can be solubilize this in this carbon disulfide and go for this reaction. So, what we get that you get this for in different viscous industry. We know that viscous is a name applicable to the rayon industry, the rayon making, for the preparation of this rayon or fiber production. Then we can go for handling or making cellophane. Every day we use cellophane papers, and these cellophane papers basically we get from cellulose, and if your cellulose has some free alcohol functions, that will be utilized to react with your CH2, carbon disulfide, And as we all know that a typical test, the detection, how you taste a sample inside a test tube or a beaker or a round bottom flask, that whether you have some liquid as a water, is present as a water or alcohol. So, the best way of doing this is the corresponding detection of this particular alcohol is, we all know, that is known as your Jantet test. So, in this making cellophane or this viscous liquid formation, this O is also, this O will be there, then this will also form in presence of a base, say sodium hydroxide. So, this is minus Na plus. So, this Jantet type of this all functionality can be developed, giving you the viscous formation or the cellophane formation, and then you can go back with acidification for the treatment of this material. So, very simple reaction like that of your Jantet test, we can utilize it. Then CS2 can be converted to another useful organic solvent, which is carbon tetrachloride. That means, if we can go simply by chlorination, that means incorporation of your chlorine, that reaction of chlorine with elemental carbon or the carbon powder as the corresponding charcoal may not be useful, but you can go very simpler way on carbon disulfide. Then, since sulfur is present in this liquid, that means in carbon disulfide, it can go for vulcanization. So, in vulcanization, it can use as accelerator. It is used in a vulcanization accelerators, then as ore flotating agent. Every time we see that all the sulfur bearing compounds for the different purposes, they are very good ore flotation agent. So, they are flotation agents, and lastly they are very good corrosion inhibitors. Or can be used in making pesticides. So, this as say is formation of this particular part, that means on a alcohol end you make it as a corresponding Jantet type of functionality, or if you can have the amine functionality, because this particular CS2 is very reactive like your carbon dioxide, because as we all know that carbon dioxide in presence of base, what it gives? You basically give you the bicarbonate. Similarly, your CS2 is also reactive in bases, in elemental sulfur, in all other cases. It is reactive with alcohol, it is reactive with amines. So, when it is reacting with amines, it is giving dithio. So, what you are doing? You are making here this particular case oxygen carbon bond you are forming. When you have this particular one also, there is dithiocarboamate, you are using amine, that means you have the nitrogen carbon bond. Okay. Then you are able to make phosphorus bearing compound with carbon disulfide, that is phosphorus sulfur bond also you can form, and you can have this particular one as this one as a simple not a very huge one from your cellulose, but you can have from methanol, ethanol or anything. So, small molecule can also be activated for your formation of your OC bond to it. So, making this particular in pesticides. So, making these pesticides, what we can have, that pesticides, if they are either Jantet based or dithiocarboamate based or the phosphorus based esters, that means not phosphorus sulfur, is the phosphorus carbon bond, because you have the phosphorus and then elaboration from the CS2N. So, you get these as a very useful organic molecule, and we can utilize this particular reactivity for carbon disulfide for making different types of these pesticides. Okay. Our next chapter basically, where we will move to the different types of your halogens, fluorine, chlorine, bromine, iodine. So, we can have also, we know that is a natural source, you can have a good source of sodium chloride, that from the ocean water also we can get the sodium bromide or sodium chloride. So, these are all from the natural sources. So, always think of the natural sources, the ores what you can have for getting these halogen and the halogen compounds. First thing what we will be talking about is your fluorine and fluorine based compound, because these are all very useful compounds nowadays. Whether you have a organic molecule where you try to introduce a fluorine on the carbon center, that means instead of your carbon hydrogen bond you try to introduce a carbon fluorine in it, or the typical fluorine based compound starting from your fluorine gas, F2 molecule. So, F2 molecule or the hydrofluoric acid or sodium fluoride, as all the time we are focusing our attention on the thing that what raw material you have, the naturally available raw material in your hand, because the country should have a good source of those raw material, otherwise you cannot compete industrially to those companies what they are producing a very low cost, at a very low cost. So, manufacture of industrial fluorochemicals. So, the general terminology we can use for industrially useful or industrially important chemicals where you have the fluorine as the constituent in it. So, it is a fluorochemical. So, we have the natural sources, as we all know, because the geologists can help you. From the geochemical point of view, we know that one of the most important material what is available on the earth crust is the fluorspar. So, the fluorspar is nothing but your calcium fluoride, CaF2, is bivalent calcium attached to two fluoride groups. So, it should be a very good source of your fluoride ions, whether you try to make hydrofluoric acid or whether you try to make sodium fluoride. Your fluorspar is the very useful one, and it also varies from quality from one particular part to the other, from one country to the other. So, the quality of fluorspar will tell you that which particular material you can handle or which you can produce. And another very important material is your fluorapatite. Fluorapatite is nothing but your fluorine bearing apatite. When it is chlorapatite, we call it as a chlorine based apatite, because it is a calcium phosphate material. Large number of areas you can have the corresponding calcium phosphate mineral attached to calcium fluoride, and the ratio, the stoichiometric ratio is 3:1. 3 molecular formula of 3 molecules of this particular calcium phosphate along with 1 calcium fluoride basically is a double salt type of thing, and you can get it as this particular form. And also other one, the third one is your Na3AlF6, which is the cryolite. So, naturally occurring cryolite. So, naturally occurring cryolite, when it is available in a amount which is huge one for a particular country, they basically use it not only for making some other thing, because cryolite is well known for the production of aluminium. So, if you have something in your hand like Na3AlF6, what do you think that this particular material you will be using for the production of sodium or for the production of aluminium or for the production of fluorine? So, you must have a very useful technique or a very easy to handle technique or industrially accessible technique, such that the production of one particular material such as your fluorine from your cryolite will be there. So, country like Greenland basically they have huge source of this cryolite. They have utilized this basically till 1963 for the production of your fluorine only, that means typical halogen. Now, if we take this particular one, that how you utilize the calcium fluoride or fluorspar, how you use for making some useful fluorine compounds. So, you go for the geological thing, that means how you go for mining. So, from geological knowledge to a mining industry knowledge, you can go for both open cast and underground mining basically to extract fluorspar. So, first thing that you have to identify whether you have fluorspar or fluorspar reserve is there in a particular area of our country and is found together with minor quantities of other minerals. So, when you take out fluorspar, we get other minerals along with that fluorspar. So, if we can separate out in the solid state or in solution, we can take the other minerals. If they are very costly minerals which is coming out with this fluorspar, we should take out or we can concentrate it for its production. And apart from your open cast mining, also we can go for deep mining. So, deep mine fluorspar, so the origin basically where from we are getting, because the character, nature and the quality of those fluorspars are different. So, you get that. So, deep mine fluorspar has to be concentrated because your calcium fluoride content is less compared to your open cast or little bit lower level underground mining. So, here only sometime it can be very less like 30% of calcium fluoride and sometime it can go up to 80%. So, you should go for mineral enrichment or ore enrichment. So, that means you have to be concentrated, whether you go for concentrated in a powder form, that means grinding and all these things, because you have a density difference in the solid powder form also, or you can go for solution leaching and then you can concentrate it. So, is basically carried out how you do this particular separation or the concentration is carried out by mechanical grinding. So, mechanically you crush it. So, mechanical grinding of the ores in crushers or ball mills, we know all the what is ball mill, and the particle size less than 0.1 millimeter should be achieved, and subsequent multi-stage flotation. That is why the ore flotation just now we are talking about. Separation of mixtures of solids on the basis of different weightabilities of the components. So, it is a very typical terminology for mineral separation, that different weightabilities. So, the material as a liquid what you are taking like your carbon disulfide or a saturated solution of sodium sulfide have different weightabilities for your fluorspar for the individual components. So, you can separate it out by flotation technique, the ore flotation technique. Then you can consider the different qualities and their utilization of these fluorspar. So, where we use, so already we know that it is a calcium fluoride. So, it will be utilized for the manufacture of aluminum, it is utilized, that means you use calcium fluoride for the production of amount of your cryolite. Then for making bricks, one of the component calcium fluoride can be one of the component in making bricks or some high quality bricks also, the high heat resistant bricks also. Then we can make it for the cement, one of the component, because some amount of calcium definitely is there. So, calcium fluoride can give you the corresponding source of calcium for the cement production. So, cement industry is also dependent on the fluorspar. Then for making glass fibers, so calcium based glass fiber, sometimes it can have also the fluorine. Then making enamel and in metal working industry. So, the people, the metallurgical engineering basically, the metallurgical engineering, they have the foundries, they have the huge workshop, we call as the foundries. So, in those foundries, if they are doing some work basically on making some alloys or some other material which is metal dependent or metal based material, they basically utilize this fluorspar for handling all these things, because it can use a different type of temperature, the fusion temperature, all these things when they go for melting processes and all these things. So, it is a very useful additive or ingredient in all these foundries for the metallurgical engineering. So, is a very useful material that we will see how this can be utilized for all other purposes, that means how you utilize this for the different purposes, or you can take it for the production of fluorine over there. Thank you very much. The next day we will continue from here for the remaining part. Okay.